Hello scholars, welcome back. This morning we're going to be looking at sets. So this is the introductory video for sets at grade 4. What is a set? Let's read the definition. A set is a group of items that share something in common, right? So they might not be exactly the same in all areas, but once they share something in common, they can be a part of that set. So you can belong to several different sets based on what you have in common with the other members of that set. The members of a set are called the elements, and we use this symbol that kind of looks like an E to say one thing is an element of this set. Sets are named using capital letters, and the elements are listed in curly brackets. So we're going to look at some examples of sets and list out the elements to show how we go about doing that. So we say once things have something in common, they share a particular trait, we can put them in the set. And they now become elements of that set or members of that set. We use capital letters to name sets. Alright, so we're going to list the elements of these 4 sets here. Set A is a set of whole numbers less than 6. They don't want all the whole numbers, they just want the whole numbers that are less than 6. What are the whole numbers that are less than 6? Do you remember what a whole number is? We did a video on the number system, types of numbers, right? So remember, the whole numbers are the counting numbers plus 0. So all the numbers from 1, 2, 3, all the way to infinity, but we include 0 as well. So if we're listing the whole numbers that are less than 6, should we also include 6 or not? It says whole numbers less than 6. 6 is not less than 6, 6 is 6. 6 is equal to 6. So 6 does not belong to this set. 6 is not an element of this set. Only the whole numbers that are below 6. So in other words then, from 0 to 5 for this particular set. So we'll say then set A would be, put our curly brackets. Remember, we use curly brackets when we're listing the elements of the set. So curly brackets, 0 is the first whole number, 1, 2, 3, 4, 5. We do not include 6 because it says less than 6. If it had said less than or equal to 6, less than or equal to 6, then we would put 6 in the mix as an element. But just less than 6, 6 is not included. Set B, how do we define set B? It's a set of prime numbers between 0 and 10. That's a very defined set. We want the prime numbers that fall between 0 and 10. What's the first prime number? Is it 1? Is 1 a prime number? Do you remember that video that we did on the number system? Is 1 a prime number? No, it's not. Remember, prime numbers have 2 factors. Themselves, right? Themselves and 1. 1 only has 1 factor, itself. So 1 is a special number. You know, 1 and 0 are really special numbers in mathematics. So we're going to give them their props, but we're not including the 1 in the set of prime numbers. The first prime number is 2. The second prime number is 3. The third prime number is 5. Then 7. The next one is 11, and that's more than 10. So we're going to stop at the 7 because it says for this particular set, set B, we only want the prime numbers that are between 0 and 10. We don't want any other prime number. Just these ones that they're interested in for this set. The prime numbers that fall between 0 and 10. So all these numbers are prime because they only have 2 factors. Only 2 numbers can go into them exactly. They can go into themselves and 1 can go into them. That's what defines them as prime numbers. And remember, we said the next prime number would have been 11, but it cannot be an element of this group. If it had just said prime numbers or prime numbers less than 20, then 11 could go, right? But this one wanted prime numbers between 0 and 10. So this is the set. 4 elements in that set. Exactly 4 in that set. Set F. How do we define set F? Days of the week that start with a letter T. So what are the elements of set F? What are the days of the week that start with the letter T? We know Tuesday starts with a T. What else? Thursday. Thursday starts with a T as well. Are there any more days of the week that start with a T? Monday, Tuesday, Wednesday, Thursday, Friday. So it's 2 days of the week start with a T. So in set F, it's a pretty small set. Very well defined set. We only wanted those days that start with a T. No other day. So there are only 2 elements in this set. Days that start with a T, only 2 elements. For G, set G, boys who love music. Boys who love music. Well, how are we going to list that? Because he didn't define it really. He didn't say boys in class 4G who love music, or even boys in the school who love music. That would be a big group, but still possible eventually to define it. But just boys in general, boys around the world who love music, how are we going to ever list out this set? So this set would classify as an infinite set for 2 reasons. One is that it's really not practical to list out every single boy around the world who loves music. And another reason is loving something is very subjective, meaning it's an emotion, and emotions, they sway, and this minute you might love the music and next minute you're not in the mood for music, that kind of thing, right? So it's not a pretty well-defined set at all. We could start off by listing the boys we know who love music. So we might say, John is always singing in the bathroom, and Jerry is always playing his guitar, and Paul always telling everybody that he loves this group and that group. So we know 3 boys who we are sure they love music. But guess what? We have to put these ellipses, and what do these mean? These dots, these 3 dots mean this set continues. We can't possibly list all the boys in the world. We can't even list all the boys in our parish who loves music. That would be very difficult to do, let alone boys in general. You see what I'm saying? So we put these down. Whenever we're given a set that is not well defined or that cannot really be practically listed, all the elements, we put these dots to say this set is nowhere near complete. It is going on and on and on. That's what these dots mean. Did a student have a question? One of you guys had a question a while ago? I heard somebody say miss. Alright, let's continue. So with sets, here we have what is called a Venn diagram. Okay, the Venn diagram is what we use to represent sets. It's a rectangle, and within the rectangle we have the sets, or we say the subsets, the smaller segments. So this is set A, set B, set C. We put a U up here to represent the universal set. So the universal set are all the elements that are being considered for this activity. Everybody who is being considered comes under the universal set in the rectangle. But each set is defined in a particular way. Some of the sets overlap, and we say they intersect. And this is the symbol we use. So in other words, some members of set A have something in common with the members of set B. So let's say set A would be children who come to school in the school bus, right? Set A. And let's say set B would be children who order lunch from the canteen, right? Set C might be something else, children who participate in music after school. So these children here, these children in the intersection of A and B, they take the school bus to school and they order lunch from the canteen. These children in here, they take the school bus to school, but they don't order lunch. They don't overlap with B. These ones here, they order lunch, but they don't come to school in the school bus. And these guys here, they don't order lunch, they don't come to school in the school bus. The ones in set C, they don't order lunch or take the school bus, but they stay back after school for music, right? So some sets can overlap, some sets don't overlap at all. They don't share any of those traits in common. The members, the elements of those sets don't share any of those common, but they are still a part of the universal set, the bigger group, right? They are a part of the school system, but they don't take the school bus. They don't order lunch. These ones out here, they don't take the school bus, they don't order lunch, they don't stay back after school for music. They don't fall into any of the smaller, more defined sets. So we said the empty or null set, these are the symbols, and it means it has no members. That set has no members, it's empty. So we either use a curly bracket with an empty space in it, or a circle with a line drawn through it. And the intersection is where the sets overlap. The union is when we combine two sets. So we would list all the members of this set and all the members of the other set in the union. So let us look at this Venn diagram then and answer these questions. We're going to list the elements. We're going to list the elements of set A. So what are the numbers that fall in set A? Remember, set A is all of this, all of that circle. So it will be 3, 5, 6, 9, and 10. All of those are in set A. So we're including the ones that overlap with set B. Everything in set A we're listing. For set B, everything in set B would be the 3, the 4, and we usually put them in order, right? Usually. All of these are elements of set B. including the ones that overlap with set A. The elements of set C would be 1 and 2. 11 and 12 are not elements of A, B, or C, right? So we said they are out here in the Venn diagram by themselves, not a member of A, not a member of B, not a member of C. Alright, now for set A intersect B, where do A and B intersect? Right here. So those elements will be 3 and 6. Set A intersects C. Does A overlap with C? No, it doesn't. They don't overlap. So they are empty. Either that or we could put that. There are no elements that overlap A and C. A and C do not intersect. It's an empty set. The intersection of A and C is empty, null. Alright, so we say this is the symbol for intersection, and that's where the sets overlap each other. So we can represent the intersection like this. This shaded part here where they overlap. Or we can say that set, and there's a set that intersects on the inside. So everything in the small set is contained within the other set. That's a way of showing the intersection of sets too. And we call this a subset. This symbol represents the union where we're combining the sets and we're listing out all the members of both sets. The empty set or the null set has no possible members. If it's not possible for you to think of any element of that set, the set is empty or null. Finite sets, we can list the elements. So for example, the first 3 sets here are finite. This set only has 4 members. Prime numbers between 0 and 10. There are only 4 prime numbers between 0 and 10. 2, 3, 5, and 7 are the only prime numbers that fall between 0 and 10. It's a finite set. We can list the members. Days of the week that start with T, just two of them, Tuesday and Thursday. That's a very finite set. Whole numbers less than 6. 1, 2, 3, 4, 5, 6 of them. There are 6 whole numbers that are less than 6. 0, 1, 2, 3, 4, 5 are the only whole numbers less than 6. And we can list them out, we just did. It's a finite set once you are able to list out the members. This set is an infinite set because there's no way, reasonably, in theory we could say, well, you know, we could get each country to have a survey. In theory, it's going to take years. And by that time, people might change their minds about music, right? But in theory, we could say each country or each parish or each town, write down the names of all the boys who say they love music. And we do that in every country and then bring it together. Even so, it's still not practical and it's still not reliable. It's not a feasible thing to do, right? So we say, given that, we're saying then, this is an infinite set. We can start by listing the ones we do know, but we accept that it's not possible to list all the elements. So for example, stars in the galaxy, that's infinite. Who can count all the stars in the galaxy? Who can count the grains of sand? Right? That's an infinite set. That's an infinite set. It just goes on and on and on. We cannot stop. We would not have enough time to sit and count every grain of sand or every strand of hair on your head. That kind of thing is just infinite, is vast. It's not feasible, possible to count them to list them. Alright, so to recap, we say a set is a group of items that share something in common. They don't have to be exactly alike in all things, but they share one thing or two things, or they share something in common. So they can belong to this set and also belong to another set and also belong to another set over there. And those sets would overlap or intersect. As well as we might have sets that do not overlap. We call those disjoint sets. They don't have anything in common. Right? And then we say the Venn diagram, this rectangle is used to represent sets. The big rectangle is a universal set. Everybody that's being considered is a part of the universal set. And then you will have smaller sets, some of which might overlap, some of which might be disjoint. And you might have some persons on the outside of all these sets. They belong to the universal set, but they don't belong to any of the other sets. You have some people like that, right? In life, you have some people, they're a part of the community, but they don't really interact with any group in the community. They are hermits. We call them hermits. Alright, so if you have benefited from this video on sets, let me know that you appreciate it by just saying thank you, miss, in the comments. And also let me know that you appreciate it by sharing the video with your friends, your siblings, your cousins, your neighbors, your classmates, everybody who you can share the video with so they can benefit as well. Now, if you look through the catalog and you don't see a video that you're looking for on a particular topic that you're really having some trouble with and you really want to master that topic, just let me know in the comments. If I have not done that video before, I'll do it just for you. If we have done it, I'll just refer you to the video, right? And if you have not subscribed to the channel, please subscribe and click the bell so you can be notified when the new videos come out so you can stay on top of things. Stay sharp, stay focused. I'll see you in the next video. Bye.